Our story begins long ago with Isaac Newton. Newton gave us the laws of motion, explaining how objects move. He also gave us a theory of gravity. It said every object in the universe attracts every other object. This force, gravity, is what makes things fall to the ground. Newton's gravity worked well for centuries. It explained the orbits of planets and the moon. It predicted the tides. But there were some things Newton's gravity couldn't quite explain. For example, the orbit of Mercury, the closest planet to the Sun, didn't quite match Newton's predictions. Scientists knew there must be more to the story of gravity. They needed a new idea, a new theory to explain these mysteries. This is where Albert Einstein enters the picture. Albert Einstein, a young physicist, was fascinated by light and gravity. He wondered if you could catch up to a beam of light, what would it look like? This question led him to develop his theory of special relativity. Special relativity said that space and time are not absolute. They are relative, meaning they depend on your motion. The faster you move, the slower time passes for you relative to someone standing still. Space and time are intertwined, forming a four-dimensional fabric called space-time. But Einstein wasn't finished. He wanted to include gravity in his theory. After all, gravity is what keeps us on Earth and governs the motion of planets and stars. This quest led him to his masterpiece, the general theory of relativity. Einstein's big idea was revolutionary. He proposed that gravity is not a force at all, but a consequence of the shape of space-time. Imagine space-time as a giant rubber sheet. A massive object like the Sun creates a dent in this sheet, warping the fabric of space-time around it. Planets orbiting the Sun are not being pulled by an invisible force. Instead, they are simply following the curves in space-time created by the Sun's mass. Think of it like a marble rolling around a bowling ball on that rubber sheet. The marble's path is curved because of the dent the bowling ball makes in the sheet. This warping of space-time also affects light. As light travels past a massive object, its path is bent slightly. This bending of light has been observed during solar eclipses, confirming Einstein's theory. General relativity is more than just a mind-bending theory. It has real-world applications that affect our daily lives. One of the most important is the Global Positioning System, or GPS. GPS satellites orbit Earth and send signals to your phone or car, allowing you to pinpoint your location. But here's the catch. Gravity affects time. Time runs slightly slower on Earth's surface than it does for the satellites in orbit. Einstein's theory of general relativity allows us to account for this time difference. Without these relativistic corrections, GPS systems would be inaccurate by several miles. Every time you use your GPS, you are relying on Einstein's brilliant insights. General relativity continues to be a cornerstone of modern physics. It helps us understand the evolution of the universe, the behavior of black holes, and the nature of gravity itself. Einstein's mind-bending theory has revolutionized our view of the cosmos and continues to inspire new generations of scientists.